It's really great to be back at Scala Days for another amazing year, and today I'll be talking about fun programming in Scala, games, algorithms, and apps. So first, a little about me. I'm a middle schooler. I've been programming for quite a bit of time now. I've programmed in Logo, NXT, Ruby, Python, C, and of course, Scala, and I really enjoy learning math and science. So first up, algorithms. I've been doing a lot in algorithms for the past year. I took the Stanford Algorithms Part 1 and Part 2 courses taught by Professor Tim Roughgarden on Coursera, and we learned a lot about making algorithms and using them from that course. In Part 1 of the course, we learned about basic algorithms such as simple searching and sorting to a little more complex algorithms such as Dijkstra's shortest path algorithm. In Part 2, we focused on more complex algorithms such as dynamic programming algorithms, and we learned algorithms such as solving the knapsack problem, and Bellman, Ford, and Johnson's algorithms. One of the places where I applied what I learned from the algorithms courses was in Sudoku solving. And you can see my Sudoku solver at this GitHub repository. So Sudoku solving is essentially a depth first search problem. And first I'll explain you two ways that we can solve Sudoku puzzles, and then I'll show you my implementation of it in Scala. So first, the simple way. You start out with a grid. From this grid, you find an empty cell and find out all of the possible values that could go into that cell. And from all these possible values, you create a bunch of new grids. I call these guesses. Some of these guesses will have cells that are empty and have no possible values. So we don't recurse on those. For the remaining ones, we recurse on them. Now for the smarter way. The smarter way is essentially the same as a simple way, but we add one crucial step at the beginning of each recursive step. This is the fill-in step. What we do is I find all the cells that have only one possible value and are empty, and I fill in those cells with that value, because I know that's what it's going to have to be. So we fill in, and then we continue with our guessing. Some of these grids don't work, but the remaining ones we guess on. Or we recurse on, I mean. Okay, so now that you've seen the two ways we can solve it, solve Sudoku puzzles, let me show you my implementation of the solver. So the core of the whole grid is the cell, each individual element. The way I have my cells is in an object cells. The way I express my cell is type cell equals to option of int. What this means is wherever I need a type that wouldn't be just option of int, but I'm trying to express a cell, I can use cell there. This is a trick I learned from taking Professor Martin Ordarski's Scala course, Sarah course. So this is useful in places such as when I'm defining my grid, instead of having to do index sequence of option of int, I can just do index sequence of cell. One thing I noticed when I was programming my Sudoku solver was whenever I had to set a value, I would always have to do sum with the value I needed to set when I was setting it. But now I have an implicit method that takes an integer and converts it to a cell by just doing sum with that number. So now let's step one level above the cell into the grid. This is a place where I originally had mutable state, but now I've switched to immutable, and I have to say it helps a lot. Before, I would some places I would be changing the grid over and over again, and I wanted to do that. But other places I wanted to create new grids. But by mistake, I would confuse the two. I would change my original grid to create a guess, and it would just cause a bunch of problems. But I couldn't even figure out what was going wrong with my code. But now with immutable state, it's a whole lot easier. So this is my class grid. I have data, which is an index sequence of cell. That's where I'm using that type cell. And then I also have box width and box height, so that I can make the Sudoku solver available to other types of Sudoku puzzles, such as 2x2 and 2x3 box Sudoku puzzles. And I know that each Sudoku puzzle has to be a square. So my size is going to be box width times box height. I do some other calculations, and then we get to the methods. The first method I have is updated. What this does is it takes a coordinate pair, x and y coordinates, and the value to be set at that location. And then I create a new grid, and I'm using the Scala collections updated method to change that value. After that, I have apply, which takes a coordinate pair and gets you the value at that location. Both updated and apply are useful because they give you the feel of a Scala collection, So then it's easier when you're reading the code to understand it. After updated and apply, I have column, row, and block 4. Column and row just give you the column or row, but block 4 takes a coordinate pair and finds the block that is enclosing that coordinate pair. And lastly, but not least, the possible values. What this does is it takes a coordinate pair and finds all of the possible values that could go into that location, but still keep the grid a legal grid. The way I'm doing this is I take the column, row, and block 4, find the union of those, and find the cells that are missing in that area. So now solving the puzzle. This is my solve method. It takes data of type grid and returns an option of grid. The reason why I have option of grid is if I do get a solution, I'll return sum with the grid that's a solution. But if I don't find a solution, I'll just return none. What I do is the first step is filling in my data, so I get my filled in grid. And then let's say it's my lucky day and my filled in grid is solved. Then I'll just return the filled in grid. But otherwise, I get all the possible guesses, and I'm doing something special here. I'm using view. Let's just skip over that for a little bit and continue to what I would have been doing without view. What I'm doing is with all my guesses, I solve them by using map, and then I find the first grid such that it's solved. So now let's go back to view. What I'm doing with view is I don't want to calculate all of the grids. I only want to keep on calculating until I find a grid that's solved. And that's what view does. Basically, it turns the collection into a lazy collection, so it doesn't keep on calculating more than necessary. Filling in known values. This is a tail recursive method because I'm going to keep on filling in until I can fill in no more. What I do is at the beginning, I find all of the possible coordinates that I may be filling in through a for comprehension. Then what I do is, again, I'm using view to find the first coordinate pair in those possible coordinates such that there's no value in it and there's only one possible value for that empty cell. And then what I do is, let's say I found a coordinate pair that matches that criteria, then I'll fill in with the updated method and recursively call fill. But otherwise, I'll just return the data because I cannot fill in anything anymore. And lastly, guessing. In my guess method, I have data of type grid, and I'm going to be returning a bunch of new grids, sequence of grid. What I do is I start the same way. I have all my coordinates, which I do using for comprehension. And here what I'm doing is I'm using collect first to find the first cell such that there is no value for it yet. Then I get all of the possible values for that cell, and then I create a bunch of new grids using map. So now that you've seen my algorithm, here are some lessons learned from creating it. First of all, avoid mutable states. It will bite you. It bit me a bunch of times in this program and other programs, and most of the time I couldn't even figure out what was wrong with my code. Second, there's always a better way. As Professor Tim Roughgarden, who taught the Coursera algorithms course, says, can we do better? And usually you can. One place where I made a big improvement was between my simple and smarter algorithms. For testing my algorithms and for their speed, I have a test suite, Crazy Sudoku Suite. In that, I have two sets of problems, which I got both of them from Peter Norvik's blog. And the first set of problems is a bunch of simple grids, and the second one is a bunch of harder grids. I ran this test suite on both my simple and smarter algorithms. My simple algorithm barely got past the first set of grids, and it was only at grid number 4 in the hard grids when I lost my patience. But with my smarter algorithm, it was done really, really fast. So there was a big improvement with just adding that one step, the fill step. And lastly, lazy can be good. If only I could convince my parents to think that way, life might be easier. So that's Sudoku solving. Next up, Google Code Jam. So Google Code, I did two things in where I got to use my algorithm skills to solve problems. First of all, I did Google Code Jam. Google Code Jam is a programming competition run by Google where you use algorithms to solve problems. So the way it works is in each round they give you a bunch of problems that you need to solve, where they give you some sample test cases, and you create your algorithm based on what they want as the solution. Then what you do is, once you've created your algorithm and you're pretty sure it's actually working, then you run it on the real test cases. So they have a small test case and a large test case. By solving those groups of test cases, this small and large, you can earn points in that round. And usually they have a cutoff, so the only top, the top X people, based on their points, will advance to the next round. In fact, the World Finals round is happening right here in New York right now at Google's offices in New York. So that's really cool. You can even win prizes from Google Code Jam if you win in the World Finals, but you have to be 18 or older, so I still have a few years to go. Another place where I got to use algorithms to solve problems was in Rosalind. Rosalind is a platform for learning bioinformatics through computer programming. Basically, the idea is it's quite similar to Google Code Jam in the way that they have a sample input and then you test it on larger inputs. And they also, both of these have time limits on how long you have to solve the real inputs. With Rosalind, it's really nice the way they teach you because they just give you a problem that you just think it's just an algorithm problem. You don't think it has anything to do with biology. But then, after you solve it, they show you how this is linked to algorithms you might use if you go into bioinformatics. So it's really great to learn how such algorithms that don't make sense at all in biology actually are related. Both Google Code Jam and Rosalind allow you to use pre-written code and open source libraries to solve their problems. So I've created a library, Google Code Jam parser, that lets you parse the input data sets for both of these types, these competitions. So let's take a look at a sample input that you might have. This is from the min-scalar product input. This was in 2009, round 1A. So the idea of this problem is you're going to be given two vectors and you need to rearrange them such that their dot product is as small as possible. So this is the sample input they give you for the problem. So the first line in this is the number of test cases. Then you get your test cases. In each test case for this problem, the first line is the amount of items in each vector. Then you have your two vectors. And this makes a test case 1. Then you also have test case 2, which follows the same pattern. Let's take a look at the output. Basically, you just have each case number with the solution for them, which for this problem is the dot product of your rearranged vectors. So let's see how you would actually solve this using my libraries. What I have my min-scalar test case, which has the two vectors and some other numbers that I got from the input. And then in solve. So the idea is we want to rearrange these two vectors such that their dot product is as small as possible. So how are we going to do that? Well, the idea is we want to multiply the small numbers in the first vector with the large numbers in the second vector. So the way I do that is I start the first vector in ascending order and the second vector in descending order, and then I find the dot product, and that's my answer. So now that we know how to actually solve the problem for each test case, but how are we going to get these test cases themselves? For that, I have my parser section. What I have is I have a converter, which is a test case sequence converter. And when I want to parse a test case with my lines, which represents the file I have, I just get the next line in my file, I convert that to an integer, and then I get the next two lines and convert them both to sequences of lines. And this is all the code you would have to write to solve this problem, and it's all made possible by my libraries, the Google Code Jam parser. So let's take a look at the library. The core of the whole Google Code Jam library is this trait, the converter. Its parameter is on a type t, and it has a method convert which takes a string and returns t. Here are some example converters that you might use. These are actually included in my library in the parser package object. For example, you might have int converter, which all it does when it wants to convert string to an integer is string.toInt. That's simple. Then you have bigint converter. You can't do string.toBigint though. You have to use the bigint. You have to use the bigint with in parentheses the string. Now you have all these converters that you can use, but how are you actually going to use them? Every time I want to convert a string to an integer, I don't want to have to do int converter dot convert with my string. String.toInt is much easier. So for that, to make it easier, I'm using a really awesome feature of Scala 2.10, implicit classes, to add on additional methods to string. Basically what the implicit class does is, you're going to have one parameter, in this case it's my string of type string, and what Scala will do is it will generate implicit defs from string, in my case, to my class. And this is an easy way to add on additional methods. The two methods I'm adding on are convert. Convert takes a type parameter t, and then it has an implicit parameter converter of type converter of t. Basically what this implicit parameter does is, it's going to look around and find a converter on that type t. Now that it has that converter, it's going to convert with my string. So now you have an easy way to convert a string to a certain type. But what if you have a bunch of strings separated by a certain thing, like a space? How are you going to convert that to a bunch of types? For that, I have convert sequence. This is also parameterized on a type t. And then what I have is the first parameter is a tokenizer. This is going to be a converter of sequence of string. By default, this is space repeating converter, since usually if you have multiple elements in a line, they'll be split up by spaces. But you can set this to another repeating converter if you want. Then I also have my implicit parameter converter, which is converter of type t, and this is basically the same thing I'm doing in convert. Now what I'm doing is I'm doing I'm converting using my tokenizer. This splits up my string, and then I'm converting each of the individual elements based on my implicit converter. And these are some ways you might use it. You might have one and convert it to an integer. That's simple. But then you might have 1 space 2 space 3. Then you can do convert sequence of int with an int. But then here, the reason why I'm leaving those empty parentheses after my type parameter is because I want to tell Scala I want to use the default parameter. So that's what I'm doing there. And let's say I have a bunch of numbers split by lines. Then I use line repeating converter. And that's how you would do some parsing. So one really cool thing with my Google Codec parser is, if you have additional types that you want to add converters to, you can make converters of your own. And one place where I do that is with the trait test case sequence converter. This is parameterized on a test case t, and this extends converter of sequence of t. The method the user defines in this trait is parse test case. What the user does is they're given lines of type iterator of string and a test case number of type integer. And their job is to produce a single test case. The method that the trait implements is convert. It has string of type string. This is from my converter. And then I have my lines. So basically I use a source to get all of the lines out of my string. And then I'm doing full left to create. I keep on creating new test cases until my iterator runs out. This is another place where I started out with mutable state, and now I've switched to immutable state. And I have to say, the code is a lot cleaner. Before I had a bunch of var where I was constantly adding on new elements and changing it in a while loop. It was messy, but now it's a whole lot nicer. So now that you have the way to convert a string to a test case, where are we going to do the input and output? Well, that happens in my problem class. What I have is, it's parameterized on a type t, which is a test case, and then I'm doing something special. After a t less than colon test case, I'm doing colon test case sequence converter. What this means is, I want a test case such that there is a converter implicitly available for that test case. And the reason why I need this is, when I'm using this method parse, I need an implicit converter, which is a test case sequence converter. And and since now I'm putting that colon test case sequence converter, it's implicitly available. So that's my problems class. And lastly, the problem launcher. This is the thing you'll actually run when you're solving the problem. What you do is, you have your problem name. You specify the name of the problem so it knows which files to read in. Then and since you're specifying the converter, which you just implement inside that class, what it does is, since this val converter is not implicitly available, it can still pass it along as a curried parameter. So that's my problem, and when I want to actually run it in my main, I just do problem solve with the parameters that the user specified. So that's Google CodeGen problem. Now let's get to the fun stuff. Yay! So first of all, apps. So I've tried many times over and over again to get Android to work with Scala, especially and Eclipse, and it just always wouldn't work. Most of the time, the main error, scala.list, did not exist. But now I've gotten a Gitter template that lets you use Scala with Android, Eclipse, and SBT. And all you have to do to create a project that works out of the box is use this Gitter template, g8-scala-android. And this isn't just a Scala project that you import and write out some Scala files. You can actually debug and run your Android project directly from Eclipse with this Gitter template. So one of the apps I wrote with my Iterator template was WordSteal. So this is how it looks. The idea is you have a start and end character, and what happens is you need to create a word that starts with the first character, ends with the last character, and has as many characters in between as possible because you get 100 points per character. Of course, if your word isn't a legal English word, it won't work. And, okay. And in fact, just a few days ago, I got this app on the Google Play Store. Don't worry, there's no need to root your phone or hack the bootloader. You can just scan this code, download it onto your phone, and launch it. The load times are a little slow, but I have a few ideas on how to make it faster. And the WordSteal code is available on my GitHub repository. So now that you've seen how the app works, I even have it on my phone right now. Now let me show you the Android part of it. This is all I have to do to make this into an Android app. The rest is just calculating letters and displaying them. This, my activity extends typed activity. Typed activity isn't actually an Android thing. What it is since I'm using this SBT Scala Android plugin, it'll automatically generate typed activity and TR, so then I don't have to use .as instance of whenever I'm getting a widget. Now that I extend typed activity, my first 4 lazy vals are all my widgets. The reason why they're lazy is if I try to retrieve them before my app has initialized, I'll get a bunch of errors because I can't access them. So since they're lazy, I'll only retrieve them when I actually need them. To get them, I'm using find view with my TR, and I get which widget I want. Then, to get my words, again, I have 3 more lazy vals, and they're lazy for the same reason. I can't access my assets until the app has initialized. And when I actually need them, I just get all of the lines in my dictionary. That's the slow part, but I have some ideas on how to make it quicker. And then, when I actually initialize my app, all I do is set the layout to be the main layout and calculate new random letters. So that's it for Android. Now let's get on to more fun stuff, games. So the place where I made games was in Minecraft mods. So I have to say, so let's do a poll. How many of you guys know what Minecraft is? How many of you guys play Minecraft? How many of you guys as kids play Minecraft? So I have to say, Minecraft's a really fun game, and I'll show you in a bit how fun it can actually get. So let me first explain you the whole setup of how you're going to create Minecraft mods. You start out with your server. I use Bucket because it lets you easily add in plugins in the form of jar files, and these are your mods. And you also have your client, which is the Minecraft you buy from Mojang. These connect via sockets. And in your server, you're going to have a plugins folder, and you drop in your mods there as jar files. And to create a mod, you can use this Iterator template. So one of the mods I created using this Iterator template is a fill area mod. And now, this is available at this GitHub repository. And now let me show you the fill area mod. Okay, so let me switch to terminal. Let me go to my Minecraft server and launch my server. And now let me switch over to Minecraft. Okay, so, okay, let's launch my server. And now I'll join my server. let's see if I can put the audio up high enough so you can hear this. So this is my beautiful Minecraft world. This is actually a theme park. And let's say I want to create a wall along this side, along here. So what I can do for that is the fill area mod lets me select a start and end location, and it lets me fill in all the elements in between with a certain block type. So first I'm going to select my start block. Select start. And now I select my start block. And now let me fly on over to the other end. And now I'm at my other end, and I'll select my end block. Oh, oopsies. Select end. So now I have my end block, and let's say I want to fill these all with stone. So what I'm going to do for that is I know the ID in Minecraft for stone is 1, so I'm going to do fill 1. And boom, I have a bunch of stone along there. But let's say I want to get a little creative. Let's say I want to create a fountain along the front of the park. Well, I know the ID for water is 8, so I can just do fill 8. And now I have a big waterfall. The cool thing with Minecraft is it's a different world. It doesn't follow Newton's laws of physics. It follows Notch's laws of physics. So now I have all this water flowing into my lake, and my lake's getting overflowed. So how do I get rid of it? Well, I just set all my start blocks to be 0, air, and my waterfall drains into my lake. Hurry up and drain him. Okay, so now let me stop my server. And that's Minecraft. So now that you've seen my mod, how it works, let me show you how I actually made it. So this is all the code I had to write to make all the blocks in between fill. So what I did was I have 2 options, start and end. And what I do is I get both of them. And then what I do is I'm doing a for comprehension over the x, y, and z values between those blocks. And then what I do is whenever I get that coordinate triplet, I get the block at that location, and I set the type to be the ID that the user specified. So that's games. Now let's get on to some more fun stuff. So in my school, I'm in the leadership class, and for the past year, I was in charge of running all the spirit days at our school. So the idea is everybody at our school has to wear a certain type of clothing, or has to spray their hair or something. Like we might have crazy hair day, that's actually a recent spirit day. Or you might have sports day, where you have to wear some sports apparel. Or you might have St. Patrick's Day, where you have to wear something green. So you have all these spirit days throughout the year. And for each of these spirit days, I'm in charge of creating project plans that explains everything that we have to do to get the spirit day working. So what I had to do previously was I had to copy the previous project plan, copy it, and change around the dates in it to create a new project plan for the next spirit day. But I would always forget 1 or 2 dates in it, and I would get points off, and it was really annoying. So to make it easier, I've created a Iterate template that lets you generate spirit day project plans, and I'll show you that. So let me switch over to terminal. Let me go to my, okay, now I'm going to use Iterate. This is a local Git repository, so I'm just going to use file : spirit day template. Now it's going to load. Okay, so since I have a lot of things to show, I'm not going to be putting in specific dates. I'll just be using the defaults, but I'll put some interesting words about this spirit day. So spirit name, Scala. So what are we going to do on Scala Days? Well, I think we should wear Scala shirts to school. So wearing Scala shirts to school. Previous homework meeting, blah, blah. So now I have my HTML file, and that's my project plan. Now let me open it up. And now you can see I have my whole project plan. So you can see in places like the dates, it's filled in. And it even generated me an email to get the announcements in our morning announcements. So you can see Scala Day. This Friday, Spirit Day, Scala Day. Show school spirit and earn homeroom points for your homeroom by wearing Scala shirts to school. This is a really good idea for a Spirit Day we should have. Maybe I'll tell the people next year to do it. Okay, so now let me get back to my slides. Okay. So speaking of using Scala in school, one of the projects I'm running is Tech Talks. The idea is we want to get people students at our school interested in technology by having people from around the Bay Area come to our school and speak about technology. So if any of you guys are in the Bay Area or can come to the Bay Area and you would like to speak to middle schoolers about technology, please contact me. We're always looking for new speakers. So in my abstract, I said that I would be showing a mind-blowing project. And I meant that quite literally. Some time ago, I got interested in working with the mind. I contacted Neuro and they sent me a Neuro headset, which I have right here. So to use the Neuro headset with Scala, I created a collection of libraries, which I call Neuro Scala. And the main library is available at this GitHub repository. So first let me show you how this whole setup works. You start with your Neuro headset, which you put on your head. This over Bluetooth connects to your computer. On your computer, you have an application running called Finger Connector, which processes the raw data coming from your headset and outputs the parsed data to a socket. Your MyScala libraries connect to the socket, parse the JSON data into classes, and your programs use MyScala libraries. So these are the different types of data types you get from my libraries. So, okay, so the first class, your data. This is basically everything. This encompasses all of the different data types that you'll get. So if you're gonna be receiving a type, you can call it your data. Then the first data type is EEG power. This contains all the different types of brainwaves that you have. All these different types of brainwaves have special things related to them. For example, delta is only there during deep sleep, and if it's there during the day, it may indicate physical defects. Theta waves are linked to daydreaming and inefficiency. That's something you don't want to have when you're coding. Okay, so, and the other ones also has things linked to them too. All these numbers are put together by Finger Connector into these two numbers, attention and meditation. These both are numbers between 0 and 100, and they're useful to you if you don't want to get too much into the details of exactly how the brain works, and you just want some numbers to play with. After eSense, you also have core signal level, which just tells you how well the headset is fitted. And all these three case classes are put together in the EEG class. Then you also have blinks, so Finger Connector can detect blinks, and it has the power with it. And also raw data, which is just the raw data coming from the headset. So raw data you'll only get if you specify that you want the raw data. And you can even get all of the numbers, all of the data types above if you're in raw data mode just by doing some computations. But Finger Connector can do it for you. So the core of the whole Neuro Scala libraries is this iterator, the Neuro Iterator. So this extends Iterator from your data, and what I'm doing is I just connect to the socket, and whenever the user requests the next Neuro data, I read the next line from the Neuro input, and through implicit conversions in my library, I convert it to a Neuro data through JSON parsing. So one of the things I made using my Finger libraries and my Neuro Scala libraries is Mind Sneaky. So last year I showed you guys a simple sneaky game that you just control with your arrow keys, but now I have a sneaky game that you can control with your mind. Now let me show you it. So the way this works is it uses the blink feature of the Finger Connector. So now let me go to Sneaky. So, I need to block that. Okay, there we go. Now let me run as a Scala application. Let me quit Minecraft. Okay, now it's launched. So let me turn mind control mode on. Okay, so now let me put on my headset and put in the ear connector. And let me turn this on. Let me go to find it. Let's see, is this connecting? Okay. Okay, there we go. Connected. Bluetooth. And by the way, this means it's trying to connect to the headset right now. Okay, yay, we're connected. Okay. This should be good. Okay, cool. So 1 blink is to turn right and 2 blinks is to turn left. So let's play. So I'll tell you what I'm going to be turning before I do that so then you guys can see me blinking. So I'm going to turn right. Now I'm going to turn right. Now I'm going to turn right. Why aren't you working today? Right. Right again. Right one more time. Right. Okay, now I'm going to turn left. Oh, yeah, why aren't you connecting? Okay, now let me get that fruit. Now let me turn right. Now let me turn left. Now let me turn left. Left again. And now let me turn right one last time. Okay, so that gives you an idea of how the game actually works. So now that I've shown you the game, it's hard to control. Looks like my mind isn't too good yet. Okay, so now that I've shown you the game, let me show you how I actually made this. So this is a demo just in case my actual demo failed. So this game is written using Akka. Don't ask me any super complex questions about Akka. I only got the demo to work a week ago with Akka. But so basically the idea is I have my 2 streams of data coming in, my Neuro iterator and my timer. So Neuro iterator, whenever it receives the data, it'll just forward it to the snaky actor. And my timer, at a constant rate, sends ticks. And this is where I update my snake and how it looks on the screen. So originally, before I switched to Akka, I had these 2 streams of data running separately. And what would happen was, since my double blink detection is happening in Neuro iterator, where I receive my blinks, because I need to check, because as soon as I get a blink, I need to check if the time since the previous blink is still less than the maximum threshold for it to be a double blink. So I was checking if it's a double blink in Neuro iterator, but since my single blink is only when it exceeds a certain threshold, a time since the last blink, that was happening in my timer. So I was detecting which direction to turn in 2 different places. So I was discussing with my dad one day, and I was thinking that if we merge these 2 streams of data, then you would basically have a blocking FIFO queue. So the idea, and then I was discussing with my dad, and my dad told me that that's what actors do. So then I learned a bit about actors, and now I have this whole setup. So my Neuro iterator is sending Neuro data to my snaky actor, and my timer is sending ticks to my snaky actor. My snaky actor, in addition to snaky actor, I have 2 other actors, my screen actor and my snake actor. So my screen actor manages what's being displayed on my screen. So snaky actor will send to it, draw, and it will reply after it has drawn with drawn. And snaky actor also sends to snake actor draw, and it will reply with drawn. And snaky actor also sends ticks, moves, and turns. So sending Neuro data. Where I'm sending Neuro data is in this Neuro sender thread. What I'm doing is I'm just connecting, and the way I connect to my Neuro iterator is my Neuro iterator will not work if the socket's closed, and the only time when the socket will be closed is when ThinkGear connector is not running. So what I'm doing is I'm using scala.util.try to keep on trying over and over again to connect to my Neuro iterator until I can. And then what I'm doing is once I've connected, then while the user is not waiting to stop reading data, Then I'll do sneaky actor. I send to it my the next thing in my iterator. And then when I am waiting to stop the reading, I just close my Neuro socket. Also, sending ticks and draws. What I'm doing is, in my frame rate update, this is my timer. Every time every time it hits that tick moment, I send to my sneaky actor a tick, and I send to my screen actor a draw. So that's what I'm doing at my frame rate. And now in my program, I have a tiny little finite state machine. So there are two states in my program. Either my game is running or it's stopped. So what I do is at the beginning, my game is going to be stopped. So my receive is stopped or else common. Or else is a method to put together two partial functions. And so then what happens is I'm in stopped mode. And let's say the user clicks the start button. Then what it'll do is it'll use context.become running or else common. And that's how I switch my state. So now I'm in running, but the user just crashed into ate itself. The snake just ate itself. So then I want to stop the game. And then I just do context.become stopped or else common. And lastly, detecting which direction to turn. So what I'm doing is, in my ticks, I'm just first of all just checking the vitals of my snake. And then I have an if statement. If the time since the last blink is greater than the double blink threshold, and the last blink is not 0, that means it's a right turn, since it's a single blink. So I tell my snake actor to turn right, and then I set the last blink to be 0. And in my blink, if the time since the last blink is still less than or equal to the double blink threshold, that means I've had 2 blinks within the double blink threshold, then I tell my snake actor to turn left, and I set my last blink to be 0. Otherwise, I just set the last blink to be the current time. So that's mind snaky. And now that you've seen what I've been doing for the past year, here's a glimpse into what's next. First of all, I like to keep on working with the brain. I think there's a lot we can learn about ourselves through analysis using these simple neural headsets. One thing, for example, I like to do is detect how do brain waves change depending on which type of activity you're doing. And also, I like to continue my work in bioinformatics. I'm still only on a basic level in Rosella, and there are a lot more problems to solve. And it's so fun learning about bioinformatics and learning about yourself through that. So and it's really fun to learn bioinformatics. Both of these are really intensive in algorithms, and I've also heard they require big data, which I've heard Scala is really good at. So if you want to follow about what I'm working on, you can follow me on my YouTube channel, where I post videos explaining projects that I work on. You can follow me on GitHub, where I post my open source projects, and you can follow me on Twitter, where I post about everything I'm working on. So last year, I said that Scala rocks. This year, I'm saying that Scala rules. Thank you. Some time for questions. So, are there any questions? Okay, yeah.
Who's your dad?
Right over there.
Congratulations.
Yeah.
How much time you spend on programming every day?
Well, usually I have a bunch of homework, but probably at least half an hour a day. But depending on how much homework I have, if I have extra time, that's what I'm doing, coding. Yeah.
Yeah. What do you think about the future of education? I saw that you're using Coursera and the biology tools.
Yeah.
What do you think those kind of education are going on?
I think those tools are really good. Many of the people in my school use that. For example, they already teach us so many things in school, but I think that just if you want to challenge yourself, that's a great place to go. And I think it's a good thing that they're doing that type of stuff.
What do you think? I mean, obviously you've got quite a lot of experience, but when you were first starting out, what do you think is a kind of good approach to get kids into programming? You know, I mean, obviously you're immensely talented. Not everyone is immensely talented, but you know, what do you think engages kids?
I think, first of all, at least for me and most of my friends, the number one thing that I'll get any kid to program is tell them that they can make their own video games. Minecraft mods. Also, like I created, last year I showed a game Callidium that I made, so that's cool. I showed my friends that. So I think I just like show them what they can really make, but then tell them what they need to learn to do to be able to do that, and then they'll get interested. I've been programming, I think, for now like 4 or 5 years.
So how many of your friends did you get addicted to programming as well, not necessarily Scala?
So how many of my friends program?
Yeah.
So I think actually, at least my school, a bunch of kids program, like many of my friends. Some of them are more just into gaming than really making games, but I've coaxed a few of them to create a few Minecraft mods of their own. But lots of my friends do programming, like most of them are learning C or Java, and some of them are even doing Scala. And with these new tools like Arduino and the Raspberry Pi, I think it's becoming even more available for kids to learn programming easily and in a fun way. Other questions?
How much are one of those headsets?
Now they actually have a Mindwave mobile available for I think $99, and there are a bunch of different types you can get from your Sky. Thank you.